All right. So the concept of limiting and excess reagent. Now, you can explain the limiting and excess reagent in this way. Think of this. When you get a cup of water, see you've got this cup of water, just a cup, okay, of water. And then you have got sugar. Now, you have got a bag of sugar. And this cup is full up to that point. Okay, now also the sugar is sealed. The sugar is sealed here. So this is a bag of sugar. You want to make uh let's say you want to make a drink. You want to drink, okay? So what is going to determine how much drink you are going to make? Are you going to use the whole water that is here, or you are going to use the whole sugar? What do you think? What are you going to use? Are you going to use all of the sugar that is given? You are going to use all of the water that is given. Okay. So sugar is too much as compared to what? To the water that is present. So you define a limiting reagent. Now reagent just means reactant in this case, okay? Limiting reactant. So you're going to say limiting reagent is the reagent that is used up first. Okay, is the reactant that finishes first or used up first in a chemical reaction. Okay, in a chemical reaction. That is what we call a limiting. Limiting means it is going to limit your reaction, it is going to stop your reaction. So something that is used up first is called the limiting reagent. And then the excess reagent is the reagent or the reactant that remains after the reaction is done. So in this case, when you add sugar to water, you are going to have some sugar remaining. So sugar is the excess reagent. Why? Because it is left after the reaction is done. So that is what we call limiting and excess. So every time, what is going to determine how much you make, how much of this drink you want to make, you are going to make is the limiting. You look at what is little. Okay, you want to prepare food. Imagine you want to prepare food. Okay, you look at the food that you have and you look at people. So what is going to determine what is going to determine how much food you are going to take is the people that are present, right? So now in this case, this example doesn't make that bit of sense the way I want to explain it. But let me say uh, you have got let's say 6 oranges, and then you have got 10 bananas. Okay, you want to make sure that each person should have one of these, and you've got only 6 people. Let me say you have got 7 people, but you want people to be each with one thing. Now here the oranges are going to be limiting. Why? Because they are going to finish up fast. They are few as compared to the what? To the bananas, which are a lot. So just start something that gets to finish first when you are reacting or when you are mixing things. Now in this case we're talking about mixing. Reacting is called the limiting reagent. You have got shimmer here and you have got relish on one plate. You are eating, but then shimmer, you see that the shimmer that you've been given, this is the shimmer that you've been given, and then this is the relish that you have. So the relish is very little as compared to the shimmer, so the relish is going to finish up fast. If the race finishes, you are going to stop eating. Why? Because it has finished. You can't be eating in shima alone without a relish. So that thing that is finished up first is called the limiting reagent because it will make the reaction stop. Does that make sense? Okay, so let's first look at one reaction that doesn't involve a limiting reagent, and then another one to understand the importance of a limiting reagent. Okay, let's say we've been given that 2 grams of hydrochloric acid reacts with sodium hydroxide to produce sodium chloride and water. So the question is, calculate the mass of sodium chloride produced. So the first thing that you always need to do when you are writing a reaction, now instead of me using hydrochloric acid, I could have used something else. Okay, let me use something else instead of, I'm going to use sodium sulfate here. That means this is not going to be hydrochloric acid but sulfuric acid we are going to use. So the symbol for sulfuric acid is like that. You need to know it. Okay. Okay, this is the question that we have. 2 grams of sulfuric acid reacts with this sodium hydroxide to produce sodium sulfate and water. Calculate the mass of sodium sulfate produced. So the very first thing that you need to do is to write a balanced chemical reaction before you answer any question that involves reactions. Write a balanced chemical reaction. So here we have what? Sulfuric acid. Okay, sulfuric acid there. And this one is reacting with a sodium hydroxide. Symbol for sodium hydroxide is like that. And they've already even told us a product to produce sodium sulfate. So sodium sulfate is like that. We already looked at how to make formulas. And the water. Okay, then the only thing that we need to do is to balance this reaction. You can see we only have one sodium here, but here we have got two sodiums. So I'm going to put a 2 in front here, like that. What else? If you look at hydrogen, I've got 2 here, and then these 2 times hydrogen, so meaning other 2. So we have got 4 hydrogens in total this side. And then if you look at this side, you only have 2 hydrogens. So I'm going to balance by putting a 2 here. Okay, so here the reaction is balanced. If you see the oxygens, we have got 4 here, 2 times this one, that gives you 6. Then we have got 4 here, 2 times this one, it also gives you 6 on the product. So the reaction is balanced. Does this make sense? Okay, so it is okay. Where? Yes. Okay, so what we are doing is this. You look at first the sodium. You can see we only have one sodium here, but here you have got 2 sodiums. So we are saying we are going to put a 2 in front here. Okay, we have balanced the sodium. Now to balance the hydrogen, if you look, we have got 2 hydrogens here. Okay, and then we have got this hydrogen, but remember this 2 is applying to everything. Is applying to everything. So meaning that we also have 2 hydrogens. So 2 plus this 2, that gives us what? 4 hydrogens. And then we are going to come this side, we only have two hydrogens. So for us to have four, we are going to put a 2 in front here.
Okay.
All right. Now look from what you've been given, 2 grams of sulfuric acid. So we've only been given the mass of sulfuric acid here, 2 grams. Okay, 2 grams of sulfuric acid. We don't know anything else. That's the only thing that they've given us. Now the question is calculate the mass of sodium sulfate produced and water. So the first thing is just calculate the mass of sodium sulfate. Where is sodium sulfate? It's here. The sodium sulfate. So we want its mass. So to be able to find that, after you've balanced the reaction, if you don't use a balanced reaction, you're going to be wrong. Okay, so after you balance it, now you come, if you see, so I'm going to say number of moles of the first one, which is given sulfuric acid. So I'm going to put sulfuric acid just down here. So number of moles of sulfuric acid is supposed to be equal to number of moles of this one which we are want to produce. Okay, sodium sulfate, like that. So if you look at the whole of this compound, there is a 1 in front, even if you can't see it. So we're supposed to say number of moles of sulfuric acid over the number in front, that's a 1. And it should be equal to number of moles of this one. It also has a 1 in front, even if you can't see it. So I'm going to say number of moles of sodium sulfate also over 1. But if you say 1 into anything, it is still 1. So that's why I'm not writing these ones. Is that okay? Okay. After then, now the question is going to be, how do you find the number of moles? So when you have been given mass, remember when you've been given mass, number of moles is going to be mass over molar mass. But if you were given concentration, okay, if you are given concentration, you know that concentration is number of moles over volume. Therefore, if you've been given concentration, to find number of moles is concentration times the volume. So you need to know these two formulas for number of moles, this one and this one. If you have concentration, use this one. If you have number of moles, if you have the mass, use this one. So those two formulas are important. So since here we have the mass, we are going to use the one for mass. So we're going to say mass of sulfuric acid over molar mass. Okay, so on this part we are saying for sulfuric acid. So I'm going to put sulfuric acid here so that someone will know that this part I'm talking about sulfuric acid, and that should be equal to, also this side we're going to say mass over molar mass. But what are we talking about this side? It's sodium sulfate. So I'm going to put sodium sulfate here. Now the next thing that we need to find is we need to get the molar masses for sulfuric acid and for sodium sulfate. So we're going to write sulfuric acid like this. We get the molar mass. So going on the periodic table, you need to use the periodic table. You see we have got 4 oxygen, so I'm going to say 4 and then times the molar mass for oxygen, if you check on the periodic table, is 16. And then you come to sulfur, you only have 1 sulfur here, so I'm going to say 1 and then times the molar mass for sulfur, if you check on the periodic table, is 32. And then you come to hydrogen, you have got 2 hydrogens, and then the molar mass for hydrogen on the periodic table is 1. Okay, so that is what you are going to do to get the molar mass. So let's calculate that. So say 4 times 16, that is 64. So 64 plus 32, this is the 32 which is here, and then this is just 32 because 2 times 1 is 2. So 64 plus 32 plus 2, that is going to give us 98. Remember, molar mass is in grams per mole. And then the next one, we also need to find the molar mass for sodium sulfate. So I'm also going to write sodium sulfate like that. Also here we have got 4 oxygens. Molar mass of oxygen is 16. We have got 1 sulfur. Molar mass of sulfur 32. And then now we have got 2 sodiums, and the molar mass of sodium is 23. Okay, so this is what we are going to punch. So we know that 4 times 16 is 64. This is just 1 times 32 is 32. Then 2 times 23, that is going to be 46. So we're going to add 64 plus 32 plus 46. That is going to give us 142 grams per mole. That's the molar mass. And then we are going to come here. So mass of sulfuric acid, we've been given the mass. You see, the mass of sulfuric acid is here. So we're going to say 2 divided by the molar mass of sulfuric acid. Okay, the molar mass of sulfuric acid is where? It's here, 98. And this is supposed to be equal to mass of sodium sulfate. We don't know. That's the question. Calculate the mass. So that's what they've asked us to find. Over the molar mass of sodium sulfate, it's there. Okay. So over 142. So what we are going to do at this stage is we are going to multiply this, cross multiply by this. So m times 98, that is going to be 98m. And that is going to be equal to, we are going to multiply this and this. Okay, so that is 2 times 142. So if I want to remain with m, I'm going to divide both sides by 98. This one cancels with this one. So we're going to say mass is equal to, so we're going to say 2 times 142 then divided by 98. So that is going to give us about 3.0 grams. This is the mass of what? Of sodium sulfate that was produced. Do you get that? Does it make sense? Okay. Now the question is also saying, and also for water. Let's also calculate the mass for water. So we've already calculated the mass for sodium sulfate, so we can remove that. Now let's go to water. So we are now interested in this one. So same, we're going to say number of moles of sulfuric acid over, what's the number in front of sulfuric acid? What number is here? What number is there? Mark, what number is there? Okay, so number of moles of sulfuric acid over 1. So it's a 1. There's no number here. If there's nothing, then it's a 1. So that should be equal to, now we go for the water. So I'm going to say number of moles of water over, we look at the number now in front. The number in front of water is 2. So we're going to say over 2. If you fail to do this, everything that you are going to be doing is going to be wrong. So make sure that you do this. Is this okay? Okay, and we know, how do you find number of moles? How do you find number of moles? So number of moles is mass over molar mass. So we're going to say mass over molar mass. For what? For sulfuric acid. And that is going to be equal to, we come here, number of moles for water again is mass over molar mass. For what? But this side is for water. Now if you see, there was a 2 down here, so we are also going to put a 2 down here. So if you leave out that 2, you are going to also get it wrong again. So we are now going to go where there is mass here. This is mass of sulfuric acid. We are going to put a 2 that is given. Okay, so we're going to say 2 over where there is molar mass. The molar mass for sulfuric acid is 98. That is going to be equal to mass, but the mass, that's the one we want, the mass for water, over 2 multiplied by, now we want the molar mass for water. So the molar mass for water, we know oxygen is 16, and then we have got 2 hydrogen, and each hydrogen is 1. So this is going to give us 18. That will be the molar mass. So to get the mass, multiply this one by that one. That is going to give you 98 m. That is going to be equal to, we also multiply this by this. So that will be 2 times 2, that will be 4, and then that 4 multiply with the 18. And then to remain with m, divide both sides by 98. So mass is going to be what? You multiply 4 by 18 and then divide by 98. That is going to be 0.758 grams. Mass is in grams. So that is how you can find the mass for water. Is this fine? Okay. So you do these calculations if they've given you only the mass, or you just know the number of moles of one reactant. But if you are given the masses of both reactants, it will be different. You need to find first the limiting reagent, and it carries a lot of marks. Okay, you need to find the limiting reagent. So let me remake the question, just the same question. Okay, so let's say the question was saying 2 grams of sulfuric acid reacts with let's say 1 gram of sodium hydroxide, and then question A was saying determine the limiting reagent. Determine the limiting reagent, and then the next one, what mass of excess reagent was left in excess. And then C, determine the mass of water produced. So we are just going to do these 3 questions. Okay, these are the questions we have. Now the first thing, remember, always write balanced chemical reaction. We already wrote the balanced chemical reaction. Sulfuric acid reacts with sodium hydroxide to form sodium sulfate, and water like that. Okay, we had put a 2 in front here, and we also put a 2 in front there. Now if you look at this question, we've been given the mass of sulfuric acid. Let's put just down. We've been given 2 grams of sulfuric acid. We've also been given 1 gram of sodium sulfate, I mean sodium hydroxide. Okay, now the question is this: how can you find, I mean, you ask yourself which one of these two is going to finish up first. Remember, when the reaction is happening, these things are reacting, so they are disappearing. So which one is going to disappear first? That's the question. Okay, which one is going to disappear first? So there are a lot of methods that you can use. Now one method that you're able to use is Of course, an easier one, you are going to assume they've not given you maybe this mass. You assume they've not given you this mass, and then you find the mass that is going to react with the sulfuric acid. Or maybe you assume that they've not given you this mass, so that you find the mass that is going to react with this one. Another formula you can use is try to use this one to determine the mass of any product that is going to be formed, and also use this one to determine the mass of any product that is going to be formed, like that. So let's use the second method I've said. So I'm going to use sulfuric acid to determine the mass of water we are going to form. I'm also going to use the sodium hydroxide to determine the mass of water that is going to be formed. And then we are going to determine which one is the limiting reagent. So that is part A. So we're going. Let's start with sulfuric acid. So we're going to say number of moles of sulfuric acid over, what's the number in front of sulfuric acid? Yes, over 1 is going to be equal to number of moles of water over the number in front. What's the number in front of 1? I mean of water. Water is here. What number is in front? It's a 2. Okay, this number here. So how do you find number of moles? We know that number of moles is mass over molar mass. Remember this side we're talking about sulfuric acid, so I'm going to put sulfuric acid here, and that is going to be equal to mass over molar mass also. But for what, this side we are talking about water. Don't forget we have got a 2 in the denominator, so we are going to put a 2 down there. Okay, now where there is mass, we're going to substitute. The mass we've been given is 2, so we're going to say 2 divided by the molar mass for sulfuric acid. Remember, we had already calculated 98. Okay, 98, and this is going to be equal to the mass of water. We don't know, that's what we're trying to find, over the molar mass for water. First we have got a 2 down. The molar mass for water we also calculated 18, right? So we're going to multiply 98. Yeah, so we're going to multiply 98 times m, that is going to be 98m, and then we're going to multiply 2 times 2 times 18. So first 2 times 2, that will give us 4, and then we're going to have 18. Oh, I've left out m here, so to remain with m, divide both sides by 98. So I think this one we even already did. Oh, even in the previous question, I just used the wrong value. This was supposed to give us, it gave us 0.7 something, but it was, yeah, it was supposed to give us the exact one is 0.735 grams. So this is the mass of water that has been produced. Take note. So when we use sulfuric acid, this is the mass of water that we are going to get. What if we use sodium sulfate? What mass of water are we going to produce? So we're also going to say number of moles of sodium sulfate over, what number is in front of sodium sulfate? 2. Okay, good. So over 2, that is going to be number of moles of water. Remember, we want to just compare water over what number is in front of water? What number is that? Okay, 2 also. So how do you find number of moles? Number of moles is mass over molar mass. This side we are talking about sodium sulfate, and this is going to be equal to also mass over molar mass. This side we have got water, but remember for both we have got a 2 down. So if we have got a 2 down, it's more like these two is going to cancel, because you have both sides a 2. Or if you want, because you have got 2's in the denominator, I'm going to put a 2 here, I'm also going to put a 2 there. Okay, so yes, so the mass of sodium sulfate you've been given is 1. So I'm going to say 1 over 2 molar mass. What's the molar mass of sodium sulfate that we found? Hmm? The molar mass of sodium sulfate we calculated was what? It was 142. You remember? 140. So we are going to say mass. Now we don't know the mass of water. That's what we are trying to find. Over 2. The molar mass for water we know that is 18. So from here again, let's cross multiply. This times this times that. So we're going to say 2 times 142. This is going to multiply with m, and that will be equal to 1 times 2 times 18. So to remain with m, divide both sides by this value. So m is going to be, pardon? Yes. 284. Yes, I've not multiplied. Yes, that is the answer. So I've not multiplied. We can multiply 2 times 144 with, yeah. So divide, okay. Divide both sides by 2 times 142, like that. You see? Yeah. You want to make with remain with m. So I'm going to say 2 multiplied by 18 divided by 2 multiplied by 142. So that is going to give us about 0.127 grams. Now, you have formed water. You have got this value, you also have this value. So which one is big? Is it 1 or 2? Which one is big? Huh? Yes, 1 is big. So if you see, the limiting reagent should always produce a small value, because why? Because the value, I mean, it is going to finish fast. Okay, so the limiting reagent should always produce a small value. All right, so meaning that if we use sulfuric acid, we are producing a big amount of water, but if we use sodium hydroxide, we are producing a small amount of water. Therefore, the one which has given us a small value is a limiting reagent. Okay. Okay, so so here, if you use this formula, we have answered two questions. You are going to say for part A, after you do all these, you are going to say therefore, since you need to write a statement when you are answering in an exam, since sodium hydroxide produces a small amount of water, than sulfuric acid, then sodium hydroxide is the limiting reagent. So using this formula, even part C, which was saying determine the mass of water produced, then we have already answered also part C. The mass of water that is going to be produced, you can even write that mass is going to be this same value, 0.127 grams of water. That is the one that is going to be produced. So we have answered two questions here actually. So you always get the small value that is produced, then that's the amount that is produced. You get that? Okay, now we can answer part B. So if one is a limiting reagent, then the other one is going to be the excess reagent. That's how questions are. So since sulfuric acid is excess, yeah, the sodium hydroxide is limiting. Okay, since sodium hydroxide is limiting, then sulfuric acid is in excess. Now question B is saying what mass of reagent was left in excess, so the first thing that you need to do is you need to determine how much of sulfuric acid reacted. Okay, because sulfuric acid is the excess reagent, meaning that some of it is going to remain. So find out how much of sulfuric acid is going to what react, and that's what we want to do. If you just find out that, then you are going to subtract from here. So you are going to say number of moles of sulfuric acid over the number in front, that is 1, is going to be equal to number of moles. So you are going to compare just these two reactants. Number of moles of sodium hydroxide over what? Over 2. Okay? So actually this is another method that you can use to determine the limiting reagent. So how do you find number of moles? Is given by mass over molar mass. This is for sulfuric acid. And that is going to be mass over molar mass. But remember there is a 2 down, so I'm going to put a 2 here. This is for sodium hydroxide. So we're going to, yes, pardon? Can you just repeat the question? Yes, this this one. This is a 2. This one. Yes. All right. So now we are going to say mass over molar mass. Now, what you do, remember the question is saying what mass of reagent was left in excess. You know that this is the excess reagent. So, what you do is take it as if you don't know this mass. So, just say you don't know this mass, okay? You want to find the mass which reacted. So, we're going to say mass. We don't know the mass which reacted over. The molar mass for sulfuric acid, we already found that was 98. And that will be equal to, now the mass for sodium hydroxide, we're going to use the same one which is here. So we're going to say 1 over 2 multiplied by the molar mass. The molar mass for sodium hydroxide, what did we find? So sodium hydroxide, you have got sodium, the molar mass is 23, oxygen, the molar mass is 16, and then hydrogen is 1. So that will give us 40, the molar mass for sodium hydroxide. And then at this point, cross multiply this by that one, then this by this one. So we're going to say 2, of course 2 times 40 here is 80. So we're going to say 80, and then that 80 will multiply with the m, it is 80m. and that will be equal to the 98 multiplied with the 1, that is going to be just 98, and then divide both sides by 80. So the mass is going to be 98 over 80. So this is going to give us 1.225 grams. So this is another method that you can use to determine the limiting reagent. So you see, the mass that is going to react in this reaction is smaller than the mass that is given. So every time the mass that is going to react is smaller than the mass given, meaning that that reagent is excess. The mass that you have is more than the mass that is going to react. Okay? Do you get that? So if this mass, let's say, was big, let's say it was 2.5 grams. So 2.5 is bigger than 2, meaning that the mass that is available is more than the mass that is going to react. Therefore, this would have been a limiting reagent. Now, the question is saying find the mass that is left in excess. So I'm going to say excess, the mass left in excess is the mass available. So the mass available, that's the one we've been given, is 2 minus the mass that is going to react, which is just 1.225. So that is what you do. What is available minus what is going to react, and then what remains is what is going to remain in excess. So the mass that is going to remain in excess is 0.775 grams if you subtract. So this is the answer that we want.